All right, people, we're going to try to do this review really quickly. It says Physics Test 3 Practice. I'm going to move quickly, all right, so the video can be short. We have a 15 kilogram box on a 22-degree slope. 15 kilograms, all right? And the first question says, what is the acceleration down the slope? Well, there's a formula for that. Acceleration down the slope is equal to g sine theta minus g cos theta mu. G is gravity, of course. So we're going to do this part, 9.8 times 22 sine. Gives me 3.67 minus 9.8 times 22 cosine times the mu, times the mu is 0.14. So it gives me 1.27. So the mu right here is 0.14. All right? So this 3.67 minus 1.27 gives us 2.4. The acceleration down the slope is 2.4 meters per second. All right? That's our answer to first part of it. All right? The second part says, what force would be needed to hold the block? Well, hold the box. Well, you could just redo this formula and change it to force right here and then put mg sine theta minus mg cosine, or you could just say, hey, the acceleration down the slope is 2.4 and the mass of the box is 15 kilograms. So you could just say F equals ma down the slope. What force is needed for a 15 kilogram box accelerating at 2.4 meters per second? So you just say, okay, 2.4 times 15. 36 newtons would hold the box still. So if you pushed on the box up the slope, 36 newtons would stop it. If no one held the box, how long would it take it to slide 90 meters? Okay, so how long would it take? The distance down the slope now is 90 meters. We know the acceleration, so we'll just take a shortcut here. XF equals 1/2 AT squared. So here's how long it would take it. So it's 90 meters down, 1/2, 2.4 times t squared. I'm going to go ahead and solve that. I'm going to say 90 divided by 1.2, because that's half of that, square root equals t. That's just doing quick algebra. 90 divided by 1.2 equals square root. It's going to take it 8.66 seconds, or we'll call it 8.7 seconds to slide down the slope. How fast would it be going when it reached the bottom? And that says 100. I got to fix that. It's supposed to say 90. How fast would it be going when it went? Well, it's accelerating for 8.7 seconds at 2.4 meters per second every second. So 2.4 times 8.7. I kept the decimals there. So like 21. 20.8 or 21 meters per second. Next problem. The next problem says a horse pulls a 1,300 kilogram sled. So here's our horse, and he's pulling a sled, and the sled is 1,300 kilograms. All right, that's very, very heavy. The sled has a mu against the ground of 0.17. What is the resistance force of the sled? Well, the sled has a mass of 1,300 kilograms, and it's accelerating down towards the earth at 9.8 meters per second squared. So its weight, 1,300 times 9.8. Its weight is 12,740 newtons, and it can only resist with 17% of that, times 0.17. 2,166. So it can resist being pulled with 2,166 newtons. All right? The horse pulls with 4,000. Okay. The horse is pulling with 4,000. So if it's doing that, then 4,000 minus this is the leftover force. What force would be left over? 1,834. So 1,834 newtons is what's actually left over in that direction after we subtract these two from each other. What would the acceleration be? F equals ma. We've got this much leftover force, and the sled weighs 1,300. So what is the A? 1834 is the force. 1,300 is the mass. A is what's left over, 1834, divided by 1,300 kilograms. 1.4. 1.4 meters per second every second. Let's keep rolling. Number 3, a car runs a flat turn at 23-meter radius. The radius is 23 meters. And the tires on this car have a mu of 0.77. Okay? Boom, we're going this way. What is the maximum acceleration of the car? Well, if the tires were 1, then we could go around the turn at 9.8. The tires are 0.77, so 9.8 times 0.77 is all you have to do for that first part. 9.8 times 0.77, 7.5. 7.5 meters per second. That's the best we can do. What maximum velocity could we do? Well, we could say centripetal acceleration is equal to velocity squared over the radius. The best acceleration we can do is 7.5. So 7.5 is equal to v squared over a radius of 23. 23 times 7.5 square root times 23 equals square root. 13.1 meters per second, or 13.2 if we wanted to round it off. That's our best velocity. All right, and then what would happen if the car went too fast? It would skirk and it would just keep going straight once it lost its traction. If the car had a mass of 1,200, what maximum force could be applied? All right, F equals ma. 1,200 is the mass of the car, and the maximum acceleration is 7.5. That's from the beginning of the problem. So it's literally just A times, what's maximum acceleration? A times the mass. So 1,200 times 7.5, 9,000. 9,000 newtons is how many newtons of force the tires could apply to keep this guy from sliding out. Last problem. No, there's two more. I'm sorry. Car goes through a vertical loop. Whoop. The radius is 7 meters. What velocity is needed? We got to make sure that we're pulling 9.8 up here or we'll fall. We have to be able to match the 9.8 of gravity or we'll fall. So basically just 9.8 is our acceleration equals v squared over r, which is 7. So 7 times 9.8 square root. 7 times 9.8 equals square root. 8.28 meters per second is needed